This example demonstrates how to create a Simulink model for using the FIO Standard Evaluation Board as a target to acquire real-time data from two sources including 1. A potentiometer and 2. An on-chip temperature sensor. Both analog inputs will be sampled and converted to digital values by an on-chip 12-bit analog to digital converter set at a 100 Hz sampling rate. The converted data will be sent to the host PC by USB Human Interface Device Protocol. The host PC will receive the data, convert the measured temperature from volts to Celsius, and finally display both data types in the Simulink simulation in real time as numerical values as well as time series plots. Before we can begin creating a Simulink model, it is important that the FIO Standard Evaluation Board is configured as shown so that it can communicate with the host PC. Important points to note are as follows. 1. Jumper J5 must be set to USB, which is in the lower position. This allows us to use USB as a power source for the board. 2. Jumper J3 must be set to the right. This enables the USB data lines. 3. Jumpers J1 must be both connected. This connects the USB data lines. 4. Jumper J9 must be set to high, which is in the lower position. This allows the board to be set to USB in application programming mode. 5. The program switch must be set to the right. This will set the board to the programming mode. For those of you who need further information about the various features and settings of the evaluation board, links to more information and data sheets will be provided at the end of this presentation. But for now, we will continue. We are now ready to connect our target to the host. Upon connection, you should see two LEDs light up. One is the power LED and the other one is the programming mode LED, which indicates that we are in the programming mode. Also notice that analog input channel 13, which is mapped to pin C3, is now connected to the onboard potentiometer. We can test whether our target is connected properly to the host by typing in the request product info command at the MATLAB command window, with USB as the first parameter and name as the second parameter. Upon entering the command, if everything is working fine, we should get the name of our target, which is FIO Standard. We will now disconnect the target from the host. If we try to run the same command again, the system gives us a warning. If we connect the target to the host again and run the same command, we should get the same correct response. If you forget the commands to use, you can type help rapid STM32 block set and it will show you a list of the most commonly used commands. We are now ready to create our first Simulink model for our target, but first I recommend that a new folder is created to save all the project files in one place. Right-click here and select New Folder. I will call this project ADC HID Demo and use that as the name of the subdirectory of the folder I just created. Double-clicking on the folder will take us to that directory here. This is important. To create a new Simulink model, we go to File, New and Model. A blank Simulink model will appear. First, we will save as. I will use the same name, ADC HID Demo, and then save. The next step is important. We must tell Simulink that our model will be using and generating code for STM32. So we go to Simulation, Configuration Parameters, and under Real-Time Workshop, we select System Target File. Browse and select Rapid STM32 Target and click OK. Under Rapid STM32 options, at the moment our target is FiOS Standard and the cross-compiler is RealView MDK. Click OK and save that once. Next, we will bring in all the blocks required to create our model. We can do that by opening up the library browser and going to Rapid STM32 block set. All models require at least a setup system clock and SysTick under device configuration. So select that block and drag and drop it in the model. Since we are using the FiO evaluation board, we can automatically compile and download the generated source code in one process. Next we go to On-Chip Peripherals. Drag the ADC configuration block to the target model and the USB HID send block as well. Please note that in the new version of the software, the USB HID send block is now called Target HID Send. And save that once. Most of the time, we need to configure this block to match our situation. In this case, we want to reach channels 16 and 13 of the analog input, and we want the resolution to be 12 bits, with output from the block as volts, using single precision format. The sample time is 10 milliseconds, or 100 Hz. If you press Help, you can see which pin is mapped to which analog input channel. Here the on-chip temperature sensors channel 16 and the ADC1 in 13 channel 13 is mapped to pin C3. We will close that for now. Click OK. Next, we will configure our HID send block by double-clicking on it. Since we are going to be transmitting single precision data, just type in single twice. The sample time of -1 instructs Simulink to just inherit the sample time from the source block that is connected to this block. In this case, when we connect the ADC to the HID send block, it will use the same sample time as the ADC block. We connect our blocks together like this. I'll just save that once more. We need to update our system model twice. The first time you can see changes in the color of the system model. Each color represents the sample time of the model. You can use the Ctrl and J hotkey to display which color represents which sample time. It is quite simple to have many colors in the Simulink model to represent different sample times. But at the moment, our model has only one sample time of 10 milliseconds, which is represented by the red color. Next, we will have to update the block diagram again, because all the sample times are still at 0. Once updated, all the sample times of all the blocks should display the correct sample time, which is 10 milliseconds in this case, and we know that we are ready to proceed with the code generation and the build process. To build our model, we just go to Tools, Real-Time Workshop, and then Build Model, or just use the Ctrl+B hotkey. Click OK, and then the build process will proceed from the code generation that generates the C source code and header files to calling RealView MDK to compile the source code and finally download the executable to the target. You can see the process and the progress in the command window here. A new folder will be created with the same name as our Simulink model, ending with _RapidSTM32. This is where our source files, both the header files and the source code, are saved. Now you can see the programming progress is taking place, and then that the process has successfully completed. The target build directory is here. The source code is all here, where you can modify it. This completes this section for creating and building our target. Next, we will proceed to creating a Simulink model for our host PC.